All right, let's get into it. Today, we are diving deep into the nuts and bolts of something that literally moves our world, but is, almost always misunderstood. We're talking about hydraulic pumps, and we're about to blow the lid off one of the biggest myths in engineering. Okay, let's do this. Have you ever just stopped and stared at a massive crane lifting steel beams like they're nothing? Or an industrial press that shapes solid metal like it's clay? That incredible, almost magical strength comes from hydraulics. It's a system that uses liquid to move mountains. And at the very heart of it all is the pump. But here's the thing, its real job might not be what you think it is. So to really understand the pump, we first have to see where it lives. And that's inside the hydraulic power unit, or HPU for short. Just think of this as the command center, the life support system that generates and controls all that incredible power. Okay, so inside a typical HPU, you've got 5 main players on the team. You've got the reservoir, that's just the tank holding all the hydraulic fluid. The motor, that's the muscle providing the raw power. Then you have valves, which act as the brains in the safety net. But right there, in the center of it all, is the pump. It is, without a doubt, the heart of the entire system. So what's its official job description? Well, a hydraulic pump takes mechanical power, usually from an engine or an electric motor, and it turns it into hydraulic energy. Now, I want you to pay really close attention to the last few words here by creating a flow of fluid. That one word, flow, it's everything. And this, right here, brings us to the core of our entire explainer. We are about to bust the single biggest, most common myth about hydraulic systems. Seriously, get ready because this little piece of information changes how you look at everything. I just love this quote because it is so direct and to the point. The common belief, what most people think, is that pumps create pressure, but that is just flat out wrong. Pumps do not create pressure. They create something else entirely. Okay, this is where it all clicks into place. A pump's job is to create flow. That's the physical movement of the fluid, which we measure in something like liters per minute. Pressure, on the other hand, is simply the resistance to that flow. Imagine this. A pump is running, but its outlet hose is just dumping fluid back into the tank. The fluid is definitely flowing, but if you look at a pressure gauge, it'll read 0. Zilch. Pressure only builds when that flow meets a roadblock, like when it has to push a heavy cylinder. So let's say it one more time. The pump creates the flow, but the load creates the pressure. Getting this straight is the key to designing safe systems and figuring out what's wrong when they break. All right, so now that we know their true purpose is to make things flow, let's check out the different ways these pumps get the job done. We're going to focus on what are called positive displacement pumps. It's a fancy name, but all it means is they trap a fixed amount of fluid and then force it out the other side. First up, we've got one of the most common and toughest designs out there, the gear pump. It's simple, it's effective, and it's built like a tank. The mechanism is just brilliant. You have 2 gears spinning. On one side, as the teeth pull apart from each other, they create a little vacuum that sucks fluid in. Then, that fluid gets trapped in the pockets between the gear teeth and the outer housing, and it gets carried all the way around the outside. Then, on the other side, the teeth mesh back together, squeezing the fluid and forcing it out the port. It's a brute force approach that just plain works. But what if you need a smoother, less choppy flow? For that, engineers came up with a much more elegant design, the vane pump. Here's how this one works. You have a rotor that spins, but it's deliberately off-center. Inside that rotor are these little vanes that can slide in and out. As the thing spins, centrifugal force slings the vanes outward, creating sealed chambers against the wall. Because it's off-center, these chambers get bigger on one side, sucking fluid in, and then they get smaller as they go around, squeezing the fluid out. It's a really clever design for a super smooth, continuous flow. And now, let's talk about the heavyweight champion of the hydraulic world, the one capable of handling absolutely insane pressures, the piston pump. Piston pumps work a lot like the engine in your car, just in reverse. You've got a spinning drive shaft that uses an angled plate to push a whole set of little pistons back and forth. As each piston pulls back, it sucks in fluid. As it pushes forward, it forces that fluid out. With a bunch of pistons firing in sequence, you get an incredibly powerful and steady flow that can overcome just about any resistance. So let's do a quick recap. We've got 3 different machines, 3 really clever ways to solve the same problem of creating flow. The gear pump uses meshing gears, making it simple and robust. The vane pump uses sliding vanes for a much smoother delivery. And the piston pump uses reciprocating pistons for its incredible high-pressure capability.
Now, to really appreciate what makes those pumps so special, let's quickly look at a totally different kind of pump, the centrifugal pump. You almost certainly have one of these moving water somewhere in your home or car.
So unlike the pumps we just looked at, a centrifugal pump doesn't trap fluid at all. Instead, it uses a spinning impeller to just fling the fluid outwards, giving it a lot of speed. The pump's casing is specially shaped to slow that fluid down, and that's what converts the speed into pressure. And this design perfectly highlights a huge weakness. Because it relies on the liquid's mass, it can't pump air. It has to be primed or completely filled with liquid before it will work, a problem our positive displacement pumps just don't have.
Okay, so we've got all these different designs. How do you decide which one to use? Well, it all comes down to the demands of the job, especially how much resistance you're going to have to push against. And when it comes down to choosing a pump, the pressure rating is often the deciding vote. A gear pump is a fantastic workhorse, right? It can handle pressures up to around 210 bar, which is a lot. But the piston pump, it is just operating in another universe entirely, capable of generating flow against ridiculously high resistance.
Let's just pause on that number for a second. 350 bar. That's over 5,000 pounds of force on every single square inch. To put that in perspective, imagine the entire weight of a large car resting on the tip of your thumb. That is the kind of immense, focused power we're talking about. And it's why piston pumps are the only choice for the most demanding jobs.
And this is exactly what we see out in the real world. You'll find those tough, reliable gear pumps in things like tractors, bulldozers, and excavators. Vane pumps are great for applications where you need a really smooth flow. And those high-pressure piston pumps? Well, they're the power behind those gigantic industrial presses and the massive mobile cranes that we talked about right at the beginning.
So, if you only take one single thing away from this explainer, please let it be this. Pumps create flow. It's only when that flow meets resistance, the load, that pressure is created. That single concept is a complete game changer. It's how a good technician diagnoses a problem, not by looking for a weak pump, but by hunting for what's restricting the system's flow. Understanding this really flips a common misconception right on its head, and it reveals the true relationship between flow and pressure. And it kind of makes you wonder, what other fundamental invisible forces are we interacting with every single day, just waiting to be explained? Thanks for watching.